Hi students, today as a part of the nanomaterials, I am going to discuss one of the very important route by which we can obtain the nanoparticles. So that particular route by which we can obtain the nanoparticles is a colloidal route. So that I am going to discuss today. That is synthesis of nanoparticles by colloidal route. So before going to discuss what is the procedure involved in this particular route and discussing about all the other things which are involved in this particular route, first and foremost we have to discuss what are the nanoparticles which are going to be obtained by means of this particular colloidal route. So the nanoparticles which are going to be obtained by means of the colloidal route are the nanometals. Not only that, we can also obtain the alloy nanoparticles, right? So by this colloidal route, we can obtain or produce the nanometals and nanoalloys. In fact, we can obtain highly stable nanometals and highly stable nanoalloys making use of this particular method, making use of this particular route. Now, for the preparation of the nanometals, we require the two substances in this particular colloidal route. The one substance is either metal salt or metal acid, and the second one is a reducing agent. So these are the two reactants or the starting materials which are required for the colloidal route for the preparation or synthesis of nanometals or nanoalloys. The one is metal salt or metal acid, and the second one is a reducing agent, students. Now, in this particular video, I am going to explain you that how we are going to produce the nano gold, making use of this particular colloidal route. Now, as we are going to prepare or synthesize the nano gold, so definitely the metal is the gold. Now, since the metal is the gold, so definitely we have to consider either the gold salt or gold acid as one of the starting material or as one of the starting material or the precursor or the reactant, because we are going to prepare the nano gold. So that particular starting material or the reactant by which we can prepare the nano gold making use of this colloidal route is chloroauric acid. Chloroauric acid. Chloroauric acid. Chloroauric acid. So this is one of the reactants which is required, students, and this is the most appropriate precursor. Precursor means what? The reactant or the one which will be converted into the another substance, right? This is the most appropriate precursor for the synthesis or preparation of highly stable nano gold. That is chloroauric acid. So based upon the previous stuff, what we need, the other metal is required. What is that? That is nothing but the reducing agent. So along with the metal, salt or the acid, we need the reducing agents. Now the reducing agent or the most appropriate reducing agent for the preparation of the nano gold, for the preparation of the highly stable nano gold is trisodium stearate. Trisodium stearate. Trisodium stearate. So these are the two reactants which are required for the preparation or synthesis of the nano gold, making use of the colloidal route. The one is the gold acid, which is nothing but chloroauric acid, and the second reactant which is required for the preparation of the nano gold, making use of this colloidal route, is the reducing agent, which is trisodium stearate. Trisodium stearate, students. Now, what are the molecular formula of these two reactants or the two precursors which are required for the preparation of the nano gold, making use of the colloidal route? So what you will do, in order to remember the structure or molecular formula of the chemicals, what you will do, you will memorize. You will write the structures or the molecular formula for 5 to 10 times on the paper. There is no need to memorize any of the molecular formula or the structure if you remember the structure or the molecular formula conceptually according to their names. You have to remember the structures or the molecular formula, students. Now, what is chloroauric acid? The name itself suggests that it comprises the chlorine, chloroauric acid, chlorine. Auric means Au, gold. Acid. Acid can be expressed in terms of which ions? H plus. That is, hydrogen will be a part of it. Now, chlorine will be a part of it. Au will be a part of it. And hydrogen will be a part of it. So, accordingly, the structure of chloroauric acid is HAuCl4. Why? Already I've explained. Now coming to the structure of trisodium stearate. Right. Sodium, Na. Trisodium means 3 sodium atoms. Trisodium. 3. Na3, right? C6H5O7. Right. So these are the two reactants which are required for the preparation or synthesis of the nano gold, making use of the colloidal route. In fact, highly stable nano gold. Right. So these are the two reactants. Now, let us see how the procedure takes place. Right. So procedure can be done in this particular chemical reactor, students. In this particular chemical reactor. Now what we need to do is, we have to take this round shaped chemical reactor, and we have to half fill this chemical reactor with water. So the blue color, it represents the water, half filled with water. And this particular chemical reactor in which the water is half filled. There are 3 provisions, in fact 4 provisions are there. 4 provisions or 4 inlet. 4 provisions. So by means of this provision, what we need to do is, we have to place the thermometer inside the chemical reactor in order to maintain the desirable temperature, in order to facilitate the reaction between the chloroauric acid and sodium stearate. Right. That depends upon the size and the shape of the nano gold particles. The temperature depends upon the size and shape of the nano gold particles which are going to be produced or synthesized. Now, this is the inlet. Inlet is nothing but another provision by which we have to pass the inert gases into this. in order to maintain the inert atmosphere. And in order to maintain the inert atmosphere, we are going to use either argon or we can use nitrogen gas. And the reason is why this inert atmosphere is being created inside the chemical reactor in which the water is present. Water and the reactants are present. The reason is during the formation of the products, the oxidation of the products takes place. So in order to avoid the uncontrollable oxidation of the products, so definitely we have to maintain the inert atmosphere. That inert atmosphere is being maintained with the help of either argon or nitrogen gas, which are the inert gases, making use of this particular inert gas inlet or provision. And this is inert gas outlet. Now we are passing the inert gas in order to avoid the uncontrollable oxidation of the products which are going to be produced during the process. And we have to remove the excess amount of the inert gas which has been entered inside the chemical reactor in order to maintain the dynamic equilibrium. So in order to maintain the dynamic equilibrium, the excess amount of the inert gas which has been passed inside the chemical reactor is expelled out by means of this inert gas outlet. Right. And this is the magnetic needle, students. This is the magnetic needle. So magnetic needle is meant for stirring the substances. And by means of this provision, we have to inject the reactants. What are the reactants? There are two reactants, students. The one is chloroauric acid and trisodium stearate. Right. Now, whenever we inject these two reactants, which are the chloroauric acid and the sodium stearate, inside the chemical reactor in which water is present, what is the role of the water? The role of the water is it acts as a catalyst. Right. Now, what are present, students? Inside the chemical reactor, what are present? The water is present, which is a catalyst. The reactants are present, which are the chloroauric acid and the sodium stearate, which are the metal acid and the reducing agents respectively. And some sort of temperature is being maintained. That is by means of thermometer. We can check the desirable temperature is being maintained inside the chemical reactor or not. And by means of the inert gas inlet, already I said, either argon or the nitrogen gas is being passed in order to maintain the inert atmosphere, in order to avoid the uncontrollable oxidation of the products. And the excess amount of the gas which has been passed inside the chemical reactor is passed outside in order to maintain the dynamic equilibrium, students. Now, under the influence of the water, and as we are maintaining some conditions inside the chemical reactor with the help of the thermometer, inert gas inlet, inert gas outlet, and all the other stuff, and with the help of the magnetic needle, what happens is the stirring of these two chemicals will take place. Stirring of these reactants means starting materials. What are the starting materials, students? The starting materials are chloroauric acid and the trisodium stearate. Now, during the processing, the chemical reaction takes place between these two reactants, chloroauric acid and sodium stearate, trisodium stearate. Now, there is no need to buttify or mug up the products which are going to be obtained when the chloroauric acid is reacted with the trisodium stearate, which is the reducing agent. Now see students, what is a reducing agent? What is the job of the reducing agent? Reducing agent is the substance which reduces the other. Now here the sodium stearate is the reducing agent which reduces the chloroauric acid. And during the reaction between chloroauric acid and the reducing agent sodium stearate, we are going to get one cation, one anion, one acid, and one salt. We are going to get the 4 products. Right? 4 products. What are they? Let's see. So HAuCl4. What is the students? Chloroauric acid, which is one of the reactant, react with trisodium stearate. What is the role of it? It is a reducing agent, reduces the chloroauric acid. Now what I said? Whenever the reaction is taking place between these two reactants, one cation is going to be produced. Now let us see what is that cation which is going to be produced during the chemical reaction between these 2 ingredients or the reactants. That cation is Au plus is going to be formed. Next, one cation, one anion is going to be formed. What is that anion? Anion is C6. So cation students, this is the cation. Finished. Anion is C6H5O7. C6H5O7 minus. Right. And what I said, one cation is going to be formed, one anion is going to be formed, along with one acid is going to be formed. What is that acid? So only one acid is possible during this reaction. What is that? H and Cl. Out of 4 Cls, one will be lost along with the hydrogen as HCl plus HCl. And what is the 4th one, students? Salt is going to be formed. Just seeing the reaction, can you guess what is the salt which is going to be formed here? What are the left? Sodium is left and chlorines are left. How many sodiums are left, students? 3 sodiums are left. And one has been lost along with the hydrogen as the HCl, and one is remained, and one is remained means 3 are remained. One is lost and 3 are remained. So 3 sodiums combines with 3 chlorines and results in the formation of 3 moles of sodium chloride. 3 moles of sodium chloride. So this is how you have to remember the chemical reaction, but need not to buttify or mug up or memorizing by writing the chemical reaction on paper by 5 to 10 times. So when the chemical reaction takes place between chloroauric acid and trisodium stearate, what are going to be formed? One cation is going to be formed, one anion is going to be formed, one acid is going to be formed, and another one is salt is going to be formed. And by seeing the structures of, by seeing the molecular formula of the 2 reactants only we have to predict what are the cations, what is the anion, what is the acid, and what is the salt which is being eliminated, or eliminated means which is going to be formed, but need not to mug up. So this reaction takes place, students, right, in the chemical reactor. And what is the job of the reducing agent? It will reduce the other substance. What is the other substance, students? The other substance is chloroauric acid. And in chloroauric acid, what are present? Au plus ions are present. And what is the reduction? Reduction is nothing but gain of electrons. Reduction is nothing but gain of electrons. Now, Au plus ions, which are a part of chloroauric acid, gains the electrons which are being released by reducing agent, which is the trisodium stearate, and gets reduced to Au0, because it is gaining the electrons and turning to Au0. That is, nucleation takes place, students. Nucleation means conversion of the tiny particles or tiny atoms or tiny molecules into solids. So gold particles have been formed. So that gold particles which has been formed should grow as the nanomaterials, right? So that job is done by the condensation process, right? So in the next step, so because we are adding the calculated amount of the reducing agent to the calculated amount of the chloroauric acid. When we are adding the calculated amount of the reducing agent, which is the trisodium stearate to the chloroauric acid, definitely this reducing agent will reduce all the Au plus ions which are a part of the chloroauric acid. This reaction takes place until or unless all the Au plus ions are being finished in the chloroauric acid. Now, so the further reduction takes place, and this reduction takes place on the surface of the gold. So we got this gold nanoparticles, right? So gold nanoparticles have been obtained, students. What I said at the beginning, I have said that making use of this particular route, that is colloidal route, whatever the nanoparticles which are going to be produced are highly stable nanoparticles. Highly stable. Why highly stable? Because so this is the nano gold particle. This nano gold particle is surrounded by this negatively charged C6H5O7 minus ions of the reducing agent, which is nothing but electrostatic stabilization. Electrostatic stabilization. I'm not going to discuss its definition in the well-defined fashion. So simply, electrostatic stabilization means the stabilization because of the electric charge. So because this nano gold particle is surrounded by so many anions, as it is surrounded by so many anions, these anions which are electrically charged, which are surrounding this gold nanoparticle, will stabilize to the maximum extent. So whatever the gold particle which is going to be formed finally is highly stable gold particle. Highly stable gold particle. Highly stable gold particle is going to be formed. Right? So in this manner, making use of the colloidal route, not only the nano gold can be prepared, even we can prepare the silver gold. That is silver. We can prepare the nano silver, we can prepare. Nano palladium we can prepare. Nano copper can be prepared. And another type of the metals, nanometals, can also be prepared based upon the availability of the appropriate precursor. Since appropriate precursor is there for the preparation of the nano gold, which is the chloroauric acid, we can easily prepare the nano gold. If appropriate precursor is present for the preparation of any of the nanometal, that nanometal can be prepared very easily making use of this colloidal route. Not only that, By the colloidal route, even we can prepare the nanoalloys also. So to conclude, whatever the nanometals and nanoalloys which are going to be produced or obtained or prepared or synthesized by means of this colloidal route are highly stable, because finally whatever the metal, nanometal which is going to be formed is stabilized by so many electrical charges. That is the reason whatever the nanoparticles which are going to be formed by means of this colloidal route are highly stable. I hope you understood this process, students, and this is very important route for the preparation of highly stable nanometals and highly stable nanoalloys. So thanks for watching, students.